So today's situation revolves around a laser, bouncing around inside an oval mirror trying to find its way back out. It comes in through this tiny gap at the top, hits the wall, bounces off, and just keeps going until it lines back up with the same gap and escapes. This is Project Euler problem 144, and it's honestly a real step up from last time. We're not just counting paths anymore, it's actual geometry with actual angles. So I gave it to Kimi K3, Claude Fable, GPT 5.6 Soul, and Grok 4.5, the same as always with no hints. And the model that's been the most reliable lately couldn't even finish this one. Okay, so here's the shape we're dealing with. Wider than it is tall, and there's this tiny slit right at the top. The beam comes in, hits the wall, and every time it bounces, it follows the same rule any mirror follows: angle in equals angle out. So it just keeps bouncing over and over, tracing its way around inside this thing. And because the slit is so narrow, the beam basically has to come back around and hit that exact same spot again before it can get out. Simple enough to say, but it's actually pretty rough to compute, because one tiny mistake in the angle math and every bounce after that is wrong as well. So the question is just, how many times does it hit that wall before it finds the way out? So GPT 5.6 Soul went for the most direct route here, and it's honestly the cleanest of the four. It just tracks the position and direction as vectors the whole time, finds where the beam crosses the ellipse, and reflects the direction around the normal line and repeats that. No converting it into angles and back, none of that, just vectors in, vectors out, and it lands on 354 bounces, which is exactly right, and it's also the fastest one here. Fable gets the same answer but takes a bit of a different road to it. Instead of vectors, it works everything out in angles. So the angle the beam's coming in at is the same as the angle of the tangent line, and then applies it to the reflection formula using those. Same physics really, just routed through trigonometry instead. And yeah, it also lands on 354, just doing a little bit more work per bounce to get there. So this one's interesting because Grok's actual bounce math is fine. Every reflection calculated is correct. The mistake is right at the end in how it decides the beam has actually gotten out. It only checks how close the beam is to the middle, left and right. It never checks whether that's actually happening near the top or bottom. And it turns out the bottom of this ellipse passes through the same narrow strip. So partway through, the beam swings past the bottom, and Grok just goes, yep, that's the exit, and stops like way too early. So it reports 161 instead of 354 due to the small error. And then the winner of last episode, Kimi K3, just never finished. The physics is same, it's the same as everyone else's. The problem is one single check, and that's the one that's supposed to catch the beam lining up with the exit. Instead of checking if it's close enough, if it's checking if it's exactly zero, like precisely zero. And computers basically never land on exactly zero. It's always just slightly off. So that check never fires and the thing just keeps bouncing forever. So one overly strict comparison is enough to break the entire thing. So four models, four pretty different outcomes. GPT landed on 354, fast and clean. Fable also got 354, just took a little bit longer. Grok stopped way too early at 161, and Kimi K3 just never stopped at all. So two right, one jumped the gun, and one that's still running. So the winner this time is GPT 5.6 Soul. It just stuck to the vectors the entire way through, no detours, and that's what made it both the cleanest and the fastest method. Fable's a really close second. Honestly, a different method, the same correct answer, just carrying a bit more overhead per bounce. Grok's mistake wasn't the hard part, the geometry was all correct. It just tripped on the part that actually sounds the easiest, figuring out if the beam actually got out, and it only checked half of what it needed to. And Kimi, last episode's winner, got taken down by one small comparison. Instead of checking for something close enough, it checked for the exact value, and that alone was enough to make it run forever. So the answer here is 354 bounces, and honestly, sometimes the hard part of a problem isn't even the physics, it's asking the right question at the very end. Same for next time, different problem, probably a different winner too.